We are going to talk about how distance and charge affects the electric force between two charged objects. As shown here, I have Q1 and Q2. When they are separated by a distance r, the electric force, the repulsive force between them, will be this strong, and I'm going to label them F and F because they are action and reaction that are going magnitude and opposite in direction. If the separation between them, the distance between them is doubled, like this one right here. Since it's doubled, take a look at this one right here. KQQ remains the same one. Q1, Q2 remains the same. However, the R has become 2R squared. Now, if you open it up, it will become a quarter. Flip it over, it will become 4 KQ1 Q2 over R squared, and this one equals to 4F. So it becomes 4 times of the, it becomes a quarter of the original force. Again, when distance is doubled, the electric force between them is quartered. But what happens if the separation becomes 3 times, is tripled? What happens to the force? Now, when the separation is tripled, our electric force will equal to 3R squared K Q1 Q2. This part is the force F, and this one here is 1/9, meaning the electric force will become 1/9 if the separation is tripled. Apply the same method, we will find when the distance between two charges quadrupled, then the force will be 4 squared, 1 over 4 squared F, which equals to 1 over 16 of the original force. Let's practice a little bit with this chart right here. Now let's see. Saying when the separation between them is R, the electric force is F, just like this case right here. Now, when separation becomes 2R, like this case right here, the electric force becomes a quarter. When the separation is 3R, the force becomes 3 squared F, so it's 1/9. So on and so far, when separation is 4R, the force becomes even weaker. When they are farther apart, becomes 5R, the electric force will become 1 over 25. Now, what happens if they are getting closer? If they are getting closer, then the repulsive force will be stronger. So if the separation becomes 1/2 the R, the force will become 1/2 squared, 1 over 1/2 squared times F. Now this one, after you do it, it's 4 times of F. Now what happens if the separation becomes this one right here? Then the force will become 9 times. What happens if the separation becomes 0.6R? Then the force will become 0.6 squared and F. So you can do the calculation all by yourself. What happens if the separation becomes this times of the original one? The force will become this times of the original force. Now, this is when the distance varies, the force will vary as well, assuming both charges remain the same. Now, let's take a look. What happens if the separation remains the same? Oh, R, 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 they are the same distance apart. Now, Q1 and Q2 carry different charges. They carry like charges. We would like to write down when Q1 and Q2 are distance apart. I'm going to write down the electric force between them is F. What happens if Q1 remains the same, however Q2, this charge becomes double of Q2? Then the force F would equal to K. Q1, the other charge becomes double of Q2, and the separation stays the same. So it would becomes 2 KQ1 Q2 over R squared. So it becomes doubled. The force will become twice as before. When the separation stays the same, Q1 remains the same, Q3, one of the charge becomes tripled, then force become tripled. Now, what happens if both of them changes? Well, take a look at F equals to K. Now the Q1 becomes double Q1, Q2 is quadrupled, separation between the same, then the force will becomes K times 6 Q1 Q2 over R squared. So take the 6 out, it will become like this. This one is 6 times of F. So make it short. When the charges changes, becomes stronger or even weaker, then the force will become product of these two will become this many times. For example, if the charge is Q1 and Q2, the force is F, and the R remains the same. When Q1 becomes 2Q1, Q2 remains the same. One of them is doubled, charge is doubled, so the force is doubled. Now, if one of them, it becomes 5 times, then see this one here, the force becomes 5 times. If this one becomes 4, this one becomes 3 times, then the force becomes product of these two 12 times. Now, if this one is 0.25 and this one is 12 Q2, you time these two numbers together is 3 times of the original force. This is when separation between two charged objects remains the same, and only the charges vary, or one of the charge becomes the amount of the charge change, or both of the amount of charge changes. That would affect the force this way. What happens is everybody changes. Let's take a look at this one right here. All right, let's take a look at the chart. When one charge carries this much Q1, the other charge is Q2, and separation between them is R. I'm going to name the force, the electric force between them is F. Now, when this one remains the same, this one remains the same, one of the charge is doubled, force will be doubled. When they remain the same, one of the charge becomes tripled, the force will be tripled. Okay, one charge remains the same, separation remains the same, the other charge becomes 1/2, then the force becomes 1/2. This one, the same, 1/3, force is 1/3. Separation stays the same, both charges changes. What do? You time these two together. Separation is the same, these two changes, so you time these two, it becomes 8 times of the original force. In this case right here, both charges remain the same as before. However, the separation becomes 1/2. Then the force will become, you have to flip 1/2, let it become 2, and you square it because it's inversely proportional to separation R. Now it will become this many times of the force, which equals to 4 times. Q1, Q2 remains the same, separation becomes even smaller, meaning they are getting closer. In that kind of case, the force would be, this is 1/4, you flip it first, so it becomes 4, and you square it. So it becomes this many times, which is 16 times. Okay, Q1, Q2 remain the same, and this one is 2. Now what do? You can flip it and square, or you can square and flip it. So you square and flip it. This is how much it is. It's 1/4. Now this one right here, these two charges are the same. So the force will become this many times as before, it becomes 1/9. How about everybody changes? Now it's easy. You time these two numbers, divided by this one squared, times F. That'll be how many times it will become of the original force. And this one here is 2F. How about this one right here? Again, 5 times 6 over 2 squared. So it becomes 7.5 force. And this one right here becomes 3 times 8 over 2 squared of the original force. So it becomes 6 times. And this one here is 0.5 times 4 divided by 0.3 squared times F. So it would be 2 over 0.09. It becomes 22.2 F. All right, this is the end of the class. Thank you for watching.